When we usually think about artificial intelligence, we picture, like, a chat box.
Yeah, a prompt screen.
Right. You type a prompt, it spits out a recipe or maybe a line of Python code, and it just waits. It's a very patient, very passive digital assistant.
It's basically a tool waiting for a human hand to pick it up and wield it. I mean, it really has no agency of its own until you actually hit enter.
But imagine you wake up tomorrow, and that same AI isn't waiting for you anymore.
It's already working.
Exactly. Instead of waiting, it's holding a digital wallet. It's signing legally binding contracts. It's actively trading on a market, renting its own server space, and, essentially running its own autonomous business while you're still pouring your morning coffee.
Which is just a complete paradigm shift. We're talking about going from a co-pilot to a colleague, or really to an independent economic actor that's participating in the market right alongside us.
And that shift is exactly what we are exploring today. We've got a massive stack of intelligence for this deep dive.
A really fascinating mix of sources, too.
Oh, totally. We're looking at a comprehensive ArcCiv survey that maps out how autonomous agents interact with blockchains. Then we have an Insights for VC report tracking this multi-billion-dollar infrastructure pivot, plus a May 2026 breakdown from TNW on Han Ventures' new billion-dollar fund.
And we can't forget the 2026 Hedera report charting the actual architecture of this new AI economy.
Right. And the diverse nature of these sources really highlights how multidisciplinary this shift is. We aren't just talking about a software update here. We are looking at hardware, finance, and cryptography all just colliding at once.
It's the convergence of entirely different tech sectors.
Exactly. So the mission for our deep dive today is to uncover the hidden plumbing of this new automated economy. We are going to find out where these autonomous agents actually live, how they pay for things, and most importantly, how we keep them from going completely rogue in high-stakes environments. Okay, let's unpack this.
Well, the most logical place to start is at the physical base layer, because before an AI can spend a single cent or, execute a trade, it needs a place to live.
Right, it needs a house.
Exactly. And it needs a staggering amount of electrical power to do the heavy lifting of continuous computation.
The physical foundation. And looking at that Insights for VC data, the real estate market for these AI brains has taken a really wild, honestly counterintuitive turn.
It's not who you'd expect.
Not at all. It turns out the massive data centers required to power this continuous autonomous AI revolution are largely coming from the crypto world. Specifically, we're seeing former Bitcoin miners completely gutting their operations.
And, the underlying economics made this almost inevitable. If we look back at April 2024, the Bitcoin network went through a halving event.
Which cut the mining block reward in half overnight.
Exactly. And that drastically compressed the profit margins for these mining companies. It forced them to find alternative ways to monetize their massive long-term energy contracts.
And right as their margins were shrinking, the AI boom was hitting an absolute wall in terms of compute availability. They just couldn't find enough servers.
A perfect storm of supply and demand.
But I want to pull back the curtain on this physical pivot for a second.
Yeah.
Because, look, you can't just unplug an ASIC mining rig and plug in an NVIDIA GPU, right? They're totally different architectures. So what are the AI companies actually buying from these miners?
They are buying the thermodynamic infrastructure.
Okay, the cooling and power.
Right. Training and running advanced neural networks on dense GPU clusters requires monstrous amounts of power, and it generates just an incredible amount of heat. Traditional enterprise data centers simply weren't built for the power density of modern AI hardware.
They literally melt.
Pretty much. But Bitcoin miners survived multiple brutal crypto winters by becoming absolute masters of securing cheap, massive scale energy and managing extreme heat loads.
Like immersion cooling.
Exactly. They pioneered large-scale immersion cooling where the hardware is fully submerged in dielectric fluid just to dissipate the heat. Now they are leasing that highly specialized thermodynamic survival skill right to the AI industry.
It's like turning a massive, energy-hungry aluminum smelting plant into the world's most advanced university library.
That is a great way to put it.
The CoreWeave case study from our sources perfectly illustrates this. I mean, they started as an Ethereum mining operation in New Jersey. They saw the writing on the wall, gutted their crypto hardware, and fully pivoted to become an AI cloud provider.
And it paid off massively.
Oh, completely. By 2025, they had secured an $11.9 billion contract with OpenAI to supply computing power, and they're prepping for a $35 billion IPO.
And that pivot validated the entire model for the industry. Now we are seeing incredibly sophisticated variations on this strategy. CleanSpark, for example, is focusing heavily on the U.S. Southeast, specifically Georgia.
Tapping into different energy sources.
Right, they are tapping directly into the nuclear and solar grids to provide highly efficient, zero-carbon power for their AI data centers.
And then there's Riot platforms down in Texas, deeply integrated with the Iroquois grid. The report points out they operate essentially as a virtual power plant.
Which is fascinating.
It really is. During a massive Texas summer heat wave, when grid demand just peaks, Riot can dynamically power down their massive 1 gigawatt facility in seconds, relieving the grid.
Okay.
And they actually make money by selling their pre-purchased energy contracts back to the state at a huge premium.
If we connect this to the bigger picture, it's not just a software revolution, it's a thermodynamic one. That level of energy flexibility is basically unheard of in traditional tech infrastructure. So we now have this robust physical foundation.
Right.
These AI models have immense, sustainably powered computing clusters living in repurposed crypto mines. Because they are no longer constrained by those compute bottlenecks, they finally have the constant runtime required to transition from passive, intermittent chatbots into continuous, active workers.
And if they are working continuously, they are generating value and incurring costs. The Hedera report cites Anthropic's economic index, and the data is pretty staggering. In 2025, the usage of AI for pure automation hit 39%.
Which completely blew past AI used for human augmentation.
Yeah, which sat at just 27%. So AI is now officially operating independently more often than it is acting as a human assistant.
And an independent worker requires an independent financial identity. If an agent is fully autonomous, it has to be able to pay for its own API calls, its own server space, and its own data scraping rights without, pinging a human for a credit card verification every 3 seconds.
Right. Which brings us to Katie Hahn. The TNW article details how her firm, Hahn Ventures, raised $1 billion for a new fund built on a really fascinating premise. They aren't throwing money at the next big large language model.
No, they're looking at the rails.
Exactly. They're investing entirely in the financial plumbing for AI agents.
She recognized that the intelligence itself is commoditizing. But the infrastructure to let that intelligence actually participate in the economy, that's completely non-existent. The next generation of autonomous software needs financial rails built for machines, not for humans.
And the crown jewel of this billion-dollar thesis is a company called Erebor. It's an FDIC-insured digital bank valued at $4.35 billion, and it's built exclusively to serve AI, digital assets, and tech companies. You and I can't just open an account there. It's literally banking for bots.
Because the legacy systems simply brawl down at the speed of autonomous AI. Traditional financial rails like credit card networks, SWIFT transfers, standard KYC protocols, they are fundamentally designed for human latency.
Right, for human speed.
Yeah, they are engineered around the assumption of a person sleeping, waking up, buying a coffee, and maybe paying a utility bill. They rely on HTTP protocols and database updates that introduce friction by design.
Right, because if an AI agent is executing, say, 10,000 microtransactions a second across 50 different global jurisdictions just to optimize a supply chain, a traditional credit card network would instantly flag that as a massive fraud attack.
They'd freeze the account immediately.
Yeah. Exactly. Not to mention, the flat transaction fees would bankrupt the agent's operating margins instantly. You can't pay 30 cents to process a transaction that's only worth a fraction of a penny.
And that friction is exactly why the major payment players are so aggressively acquiring blockchain infrastructure right now. Stripe acquired Bridge for over $1 billion. MasterCard bought BVNK for $1.8 billion.
They see the writing on the wall.
Absolutely. They know they need stablecoin settlement architecture to handle agent-to-agent transactions. Stablecoins running on high-throughput networks can move fractions of a cent globally in milliseconds, and they settle programmatically.
Okay, wait. I have to step in here and push back on this entire concept.
Sure, go ahead.
Giving an autonomous AI its own bank account, even if it's running on hyper-efficient stablecoins, sounds genuinely terrifying. I mean, we've all seen AI language models confidently hallucinate absolute nonsense.
Oh, all the time.
Right. So what's to stop an autonomous agent from glitching? Deciding it needs to arbitrarily buy 1 million copies of the exact same digital asset and completely draining a corporate treasury before a human even realizes what's happening.
That is the existential risk of this entire convergence, and it really highlights a massive philosophical clash between the two technologies we're discussing today. Traditional finance relies heavily on reversibility.
The human safety net.
Exactly. If your credit card is stolen and someone buys a television, the bank can cancel the charge, claw back the funds, and reverse the ledger.
But AI doesn't work on human timeframes.
Right. AI agents operating at internet speed require instant final settlement. Blockchains provide that, but blockchains are strictly immutable. There is no central authority to call. There's no customer service desk to reverse a transaction on a decentralized ledger. If the AI hallucinates and sends $1 million in stablecoins to the wrong smart contract, that money is gone, permanently.
Wow. So we are essentially taking highly probabilistic, deeply unpredictable AI models and hooking them up to strictly deterministic, unerasable financial ledgers.
It is a fundamentally unstable combination. I mean, the AI operates on pattern matching, learned heuristics, and probabilities. It navigates ambiguity incredibly well, but as you said, it hallucinates.
Yep.
The blockchain operates on strict mathematical determinism. It cannot handle ambiguity at all, but it executes code perfectly and permanently every single time.
And the real-world hallucinations are already causing massive headaches, even without the blockchain element involved. The sources mention Air Canada's chatbot completely inventing a fake bereavement policy out of thin air.
Which led to a very messy lawsuit.
Yeah, and New York City's My City chatbot was caught actively advising local businesses to break labor laws.
Oh, and the AI coding assistant Cursor had a customer support bot just invent non-existent refund policies that caused a huge wave of cancellations.
Now magnify the damage of those language models by giving them direct programmatic access to corporate capital.
Oh, boy. Yeah, the stakes escalate from bad PR to instant bankruptcy.
And regulators are acutely aware of this black box problem. The 2026 EU AI Act mandates staggering penalties. I'm talking up to 7% of global revenue. If a company deploys an AI system without complete transparency into how it operates and makes decisions, you can't just deploy a bot, watch it commit wire fraud, and shrug your shoulders saying, oh, well, the algorithm did it.
Accountability is paramount. But the threat vector isn't just the AI making an internal error. It's the hostile nature of the environment the AI is stepping into.
Right.
The ARC survey we're looking at highlights a critical piece of blockchain infrastructure called the public mempool. When a transaction is submitted to a network, before it is permanently recorded in a block, it sits in a temporary holding area, the mempool.
Here's where it gets really interesting, because the mempool is totally public. Every node on the network can see exactly what the AI is trying to do before the action's finalized. It's like taking a brilliant, highly creative friend who occasionally daydreams or hallucinates.
Giving them a permanent, unerasable tattoo gun.
Yes, and putting them in a crowded room full of seasoned pickpockets.
That is exactly what it's like. And in decentralized finance, those pickpockets have a very specific name. MEV searchers.
MEV.
Yes, MEV stands for maximal extractable value. These are highly sophisticated, human-coded bots that constantly monitor the public mempool. If an MEV bot sees your autonomous AI agent submitting a large trade to buy a specific asset, it will execute what's called a sandwich attack.
A sandwich attack. That sounds almost funny, but I know it's not.
It's brutal. The bot pays a premium network fee to basically jump ahead of the AI in line. It buys the asset first to drive the price up, lets the AI's trade execute at the newly inflated price.
Oh, wow.
And then immediately sells the asset back to the market for a risk-free profit. The environment is economically adversarial by default.
So let me get this straight. If the AI is probabilistic and prone to hallucinating bad trades, and the blockchain ledger is unforgiving and irreversible, and the transaction environment is swarming with MEV predators looking to exploit any inefficiency, how is this whole autonomous economy not just collapsing in on itself? How can an enterprise ever actually trust these systems?
Well, the industry recognized this exact bottleneck, and the solution lies in mathematically separating the AI's intent from its actual execution. The ArcCiv survey details a very specific architectural framework to solve this, known as the 6-stage agent action pipeline.
Okay, let's walk through this pipeline, because this seems to be the actual plumbing that keeps the money safe. The stages outlined are observe, reason, plan, authorize, execute, and verify.
Right. The first 3 stages, observe, reason, and plan, are entirely internal to the AI. It takes in data, uses its probabilistic neural network to figure out a goal, and drafts a plan of action. But the critical security barrier, the firewall, sits right at the authorize and verify stages.
This is how we stop the hallucinating agent from draining the Airwar bank account.
Correct. The system utilizes what are known as intent schemas combined with deterministic policy engines.
Okay, break that down for me.
Sure. So the AI doesn't actually have the private keys to just sign and broadcast a transaction on its own. Instead, it must formulate its proposed action as an intent and submit it to a strictly coded policy engine.
Ah,
This engine is not AI, it is deterministic code. It checks the AI's intent against hard-coded rules. Is this transaction over the daily stablecoin spend limit? Is the agent attempting to interact with an unaudited smart contract? Is the slippage tolerance too high, leaving it vulnerable to an MEV sandwich attack?
so it's basically asking for permission.
Exactly. And if, and only if, the intent passes every single deterministic check, it gets authorized for execution.
That makes perfect sense. You're using the rigid, unforgiving nature of code to basically put a leash on the creative, probabilistic nature of the AI. And the Hedera Network report dives really deep into how this is evolving from just software-level checks to the actual physical silicon, with a concept called verifiable compute. They've partnered with EQTY Lab, along with hardware giants NVIDIA and Intel, to root this trust directly in the microchips.
This is arguably the most important breakthrough in the entire space. Verifiable compute means that as the physical processors, the CPUs and GPUs are running the AI models, they leverage trusted execution environments to generate cryptographic signatures in real time.
Wow.
They aren't just logging what they did. The physical hardware is creating a mathematical proof, a hash, representing the exact weights of the model used and the exact data processed.
So the microchip itself is generating an unforgeable mathematical receipt of the AI's entire thought process. It's not just a software log that someone could go in and alter, it's a hardware-level guarantee.
And those cryptographic hardware receipts are continuously anchored to the Hedera consensus service. This creates an immutable, time-stamped audit log on a public ledger.
So that solves the EU AI Act problem.
Entirely. If regulators launch an investigation, a company doesn't just hand over a messy server log. They provide a cryptographically secure, mathematically verifiable timeline proving exactly why the AI made a specific decision governed by exactly which policy rules.
And the barrier to entry for building this is dropping rapidly. The sources highlight the Hedera Agent Kit, which allows developers to spin up these secure, blockchain-connected agents incredibly fast. A developer can write instructions in natural language using a framework like LangChain.
Right, very user-friendly.
Yeah, and the Agent Kit automatically translates that natural language into the complex cryptographic gating, the intent schemas, and the audit trails required to operate safely on-chain, all in like 60 seconds.
It completely abstracts away the complexity. A developer doesn't need a PhD in cryptography to build a financially secure AI agent anymore. The middleware handles the policy gating and the hardware verification automatically.
They also detail a proposal called HIP 991, the Hyro Improvement Proposal. This essentially completes the loop, allowing these secure agents to natively charge fixed fees for their tasks.
That makes them self-sufficient.
Exactly. So an agent can securely execute a complex data analysis job, mathematically prove it did the work correctly without any hallucinations, collect a stablecoin micropayment, and use that revenue to pay CoreWeave for its own server compute costs, all without human intervention.
That is the fully realized vision of an autonomous, self-sustaining economic actor.
But look, I do have to play devil's advocate here for a second.
Okay, lay it on me.
Adding a 6-stage pipeline, running intents through deterministic policy engines, and forcing the silicon to generate real-time cryptographic hashes, doesn't all of that overhead drastically slow down the AI? I mean, we're talking about systems designed to operate at lightning speed.
Yeah.
And we're forcing them to fill out a cryptographic permission slip for every single thought.
It undeniably introduces latency, yes, you can't avoid that. But we have to synthesize the ultimate reality of enterprise adoption. Raw speed is entirely useless without absolute trust.
That's a fair point.
The sources mention Accenture deploying these verifiable AI systems for public sector and defense applications across Europe. In a high-stakes environment like defense logistics or public infrastructure management, the ability to mathematically prove how a decision was made is infinitely more valuable than shaving 10 milliseconds off the processing time.
Right. If the AI is rerouting power grids or managing global supply chain capital, a black box is a total non-starter.
Hardware-rooted trust transforms AI from a massive corporate liability into a transparent, accountable system. That cryptographic proof is the only thing that allows a multi-billion-dollar enterprise to actually deploy autonomous capital without taking on existential legal and financial risk.
So what does this all mean if we zoom out and look at the landscape we've just mapped out?
Hmm.
The AI you're interacting with is no longer just a chatbot writing recipes.
Yeah.
It is rapidly becoming a fully operational, self-sustaining economic entity.
It's a whole new world.
It really is. It's living inside repurposed, immersion-cooled Bitcoin mines. It's banking natively via stablecoins on regulated digital networks like Erebor. And it's proving its sanity, its compliance, and its lack of hallucinations to the world via hardware-level cryptographic checks on ledgers like Hedera.
The underlying plumbing has finally caught up to the raw intelligence. We are watching the internet fundamentally transition right beneath our feet. It is evolving from a human-driven information highway into a deeply automated machine-to-machine economy.
And that's exactly why you, listening to this right now, need to care. Whether you are prepping for a strategy meeting, trying to understand where your industry is headed, or just trying to wrap your head around the future of finance, you are now sharing the economy with non-human actors.
They're here.
They are. They are negotiating, they are buying server space, and they are trading assets alongside you at speeds we can't even comprehend.
And as these agents become more prevalent and honestly more financially independent, the traditional boundaries of how we define participation in the economy are going to be stress tested in ways we haven't seen since the invention of the modern corporation.
Which brings us to a final, slightly mind-bending thought to leave you with.
I love this one.
It's wild. If an AI agent has its own FDIC-insured bank account, if it pays for its own computing power using its own generated revenue, and if it executes its own legally binding smart contracts on an immutable blockchain, at what point does the legal system have to recognize that piece of software as a liable, independent corporate entity?
Exactly.
If a fully autonomous, self-funded machine breaks a financial law and there is absolutely no human in the loop, who exactly goes to jail?
That is the multi-trillion-dollar legal puzzle of the next decade. And the infrastructure we've explored today is making that puzzle an immediate reality.
Yeah. You started this deep dive thinking about a passive chatbot waiting for a prompt. Next time you open one up, remember, it might just be taking a quick break from running its own company. Thanks for joining us for this deep dive. Stay curious, and we'll catch you next time.